Bismillahirrahmanirrahim. Assalamu alaikum warahmatullah. Dear students, this is chapter 6 and week 10, in which we will cover this chapter. The chapter is uploaded to the Blackboard as a PowerPoint presentation, and the lecture will be delivered in this video in two parts. The first part will be about 40 to 45% of this chapter, and the second part is going to be finishing up the chapter, or it might be another third video if the second video will not finish up this chapter. This chapter is about data types, and in which we'll go over primitive data types, character string, array types, and record types, list types, union, pointers, and then also we'll cover the optional types, type checking, strong typing, type equivalence, and theory and data types. If we have found that some parts of this chapter are not significant, then we can skip them in the recording, and also we'll filter the PowerPoint presentation by deleting these slides. But whatever is covered in this video is going to be considered for this lecture. Data type. What is a data type? This concept is not new for you. You have seen it in many different programming languages and also some scripting languages. A data type, it's a collection of data objects and a set of predefined operations on those objects. And then also we need to differentiate between these three concepts, data type, a descriptor, and object. So a data type is a collection of data objects. A descriptor is a collection of attributes of the variable, while an object is an instance. It is representing an instance of a user-defined data type. We will be left with what we call one design issue for all these data types, which is what operation that defines these data types and how are they specified in your programming language or a scripting language. We will go into details of these primitive data types and the different operations performed on those data types. The programming languages, almost all of them provide this type of data types called primitive data types. These primitive data types is a reflection of the hardware, that some of them they require little or no hardware support, and some of them require specific hardware support. For example, let us take this integer data types as part of primitive data types. This is a reflection of hardware because it represents a mapping between the hardware and the hardware and the software, specifically in terms of digital or binary digits, as we see in some machine languages, for example. The integer data types, they might be as many as 8 different integer data types in a specific language. For example, Java assigned integer could be byte or short or integer or long. In C or C++, you have also short int, short or long int, and short unsigned int, signed int, signed long, unsigned long. All these are integer data types. For floating point data types as part of the primitive data types, this represent the real numbers, and sometimes they go only as approximations, since sometimes they can be multiple numbers after the decimal point. There has been two main types for these floating point data types, these representing floating and double, sometimes more. We have long float, long double sometimes, but these are the main ones, float and double. And this also require hardware support. There are two different standards, the IEEE floating point standard, and also a standard called 754. This is part of the system that was first implemented on those floating point data types in the 70s during the design of Fortran and also Pascal and all these languages. Complex data types could be some languages need support for these complex data types, and these complex data types represent two different parts. We call them real part and imaginary part, because an expression like this, for example, it has an operands, this operand and this operand. When this is operator, this 7 can represent a real part, which is known number, while this 3 is imaginary part, since it depends on the value of this variable, whatever it is. So these complex data types sometimes in Python, for example, they present complex representation. For business application, for example, like COBOL, we use decimal data types, and these are stored as fixed numbers for decimal digits. It is sometimes very accurate as one of the advantages, but sometimes they are have limited range, and also they can be considered as a waste of memory space, specifically if you're talking about multiple digits after the decimal point, multiple digits, like sometimes 24 types of digits after the decimal part. If I have an example here working, I could show you this. For example, let me see if I can show you this from the structured query language. This is, for example, a number, which is a whole number as an integer number. But for example, if you would like to see the number of decimal places after this point, I'm trying to get an average for these salaries. So the average is 2073. But if you look at the number of digits after the decimal point, there are countless numbers of digits after the decimal point. This represents what we call waste memory. All this requires specific bytes to be represented in the memory addresses. Another data type is Boolean, which is simplest of them all, because it represents two values, either true or false, the Boolean, and also could be represented as bits for 0 and 1, such that 1 represents the true and 0 represents the false. It is readable in terms of readability, because true, as spelled out T-R-U-E, true, it means positive. False, it means negative. And here you represent the values 0 and 1 by, logically speaking, 1 is true and 0 is false. And it has a lot of readability and writability advantage. Also, there is a character data types, which is almost stored as a numeric coding. It is stored as numeric coding depending on their ASCII value, which is American Standard Code for Information Interchange, because this coding represent all these characters, which is 254 characters as digits. I can show you this example here from the ASCII table, where you will see that the letters, all these letters, like capital letters or small letters, or even just some symbols, or like symbols like this: percent, open parentheses, closing parentheses, star, pound, exclamation mark, and this bracket and close bracket and underscore. All these, they are represented by binary numbers, either hexadecimal or octadecimal or decimal. For example, here the character A, the letter A, can be typed by the number 65, while the letter small a can be typed by this number 97 from the ASCII table, which is, as I said, American Standard Code for Information Interchange, which is it is a 1 byte code. So every character represent one single byte. That's what it needs to be stored in the computer memory. And it could be represented also as 32-bit Unicode, and this is supported by many programming languages, starting from Fortran 2003 onwards. And then also we can cover this string data types, which is sequence of characters put together to represent a string. They are of specific lengths. It could be static or it could be dynamic. The operation that could be done on the character string could be assignment operation, or comparison using logical expression, relational operators, equal, greater than, less than, greater than or equal to, less than or equal to, not equal to. All these are comparison operation can be performed on the string. So you can compare a string by a string, or compare a string from a string by using this. And I can compare, for example, which comes before, for example, Adam. Is Adam greater than Paul? So you have to actually compare the first character A and P. See the value of A and the value of P. For this A, for example, 65, and Paul is P is 80. So P comes is greater than 65, so that Paul is greater than Adam. So this is how you can actually compare a string, basically. Catenation also one of the operations that can be performed, which is joining or merging strings together. A string can be joined to string. For example, you can merge a full name to the last name, and you can actually concatenate a space between a first name and a full name as a string character. Substring reference, specifically if talking about arrays, this is also could be part of the operation performed on the character string. Pattern matching, specifically of password. If you'd like to compare a password stored in files and password entered from the keyboard, for example, we can use character string as well in pattern matching, coding. Character string type in certain languages like C and C++, as you could see, this is a character array. Data type char, name is the name of the array, 15 is the size of the array, equal, this is an assignment statement, and this is the string, which is, it could be 50, it should be 15 or less, or it could be just declared without assignment statement. In this case, character string can be dynamic, entered from the keyboard. This is also in Snowball 4, in Fortran, Python, Java, and C#, Swift. All these use this character string type In Java and C Sharp and Ruby, they have what's called the string class as a data type used for that. And also in Perl, JavaScript, Ruby, and PHP, they have pattern matching coding for these scripting languages. Character string are implemented as static lengths. If it is implemented as static length, it is considered as compile time descriptor. And if it is performed as dynamic length, it will be considered in runtime as a runtime descriptor. So this is two types of implementation of this character string, either static length or dynamic length. So simple static lengths compile time description, and dynamic lengths on runtime description, which is the allocation, and the allocation of memory location is the most design issue that can be faced on those character arrays or character strings. As we defined descriptor, a descriptor is simply an area of memory that stores the attributes of a variable. What kind of attributes we talk about? We talk about the variable type, the variable size, the variable scope, the variable lifetime. All these are attributes of the variable. So if the attributes are all static, then as I mentioned, descriptors are required only at compile time. But if the attributes are all dynamic, so this the descriptor is used by runtime system only, and it is used in this case for type checking and building the code for allocating the memory location for these variables. This is a comparison between compile and runtime descriptions. So in compile time description for static strings, you have static string length and address, but in runtime description for limited dynamic strings, you have limited dynamic string, maximum length, current length, and address. Here you are comparing the descriptors in terms of runtime and compile time. User-defined ordinal types. This is the one in which the range of possible values can be associated with the set of positive integers, only positive integers. So it doesn't actually represent the negative integers. We call user-defined ordinal types, and this can be used as integer data types or character arrays in terms of converting it to digits, and also Boolean, converting true or false to digits, which is 0 and 1. Another data type called array types, which is could be homogeneous, a homogeneous array which is of the same type. So they are defined by having the position for these elements one by one, set from the first array element to the last array element, starting from 0 index. There is a lot of design issues for array. For example, what types are legal for subscripts? Subscripts means indexes, or we call them subscripts or indexes, or the elements, not the values themselves, but the elements, the position of each element in that array. Also, one of the design issue is the expressions in the element. Are they referencing the specific range checked? Are they of the same type or different types? Later we're going to talk about ragged arrays and tabular arrays, and you will see that this is part of the design issues represented by that type. Ragged or rectangular? Ragged or rectangular? Are they ragged or rectangular multidimensional array? This could be seen by looking at the multi-dimensional array. So for example, here in this example, let me just go down here to show you the ragged, this is jagged array, and this is rectangular array, in which you will see rectangular array is actually a full size array represented by rows and columns, while this one is different from one column to another. So this is one of the design issues. Here I would like to talk about array indexing, which is subscripting, which is a mapping from indices of elements. So the syntax here, you see array name, and here the list of indexes or subscripts. Each one of them represent an element inside the array. If you look at this example, the name of the array is name, A, B, C, D are the elements, and the position are 0, 1, 2, 3, which is these are subscripts of that array. For example, here if you look at this example, you'll see that here this is an empty bracket in which the size has not been mentioned, but that means they are 1, 2, 3, 4. So automatically the programming language will assign a number for this size. I would like to here talk about the categories, array categories, with respect of subscript binding. There are different categories. Static, for example, fixed, stacked, dynamic, fixed heap, dynamic, and heap dynamic. What is the difference between them? The static subscript, these ranges are statically bound and storage allocation is static. That means everything is done before runtime of the program. One of the advantage of static array category is efficiency. There is no dynamic allocation, so it is very efficient because the number is already static and known to the program. Fixed stack dynamic, these subscript ranges are statically bound, but the allocation is everything is done at declaration time, which requires some sort of space management. So we'll talk about space efficiency is part of the advantage of this type of fixed stack dynamic. Fixed heap dynamic, this is similar to fixed stack dynamic, such that the storage binding is dynamic but fixed after allocation. That means the binding is done when the request for the storage allocation has been done. Heap dynamic means binding of subscript ranges and storage allocation is dynamic and can change any number of times. So the heap dynamic, it range the subscript range, there is a range of allocation, so it is some sort of flexibility here, and can change any number of times during the program processing. It is flexible, one of the advantages, and also the array can grow or shrink according to the execution of the program. In C and C++, array, we use static as a word. This is a modifier that can be used for fixed stack dynamic. And also we provide fixed heap dynamic arrays for C and C++. Usually in C# we use what we call array list, and also Java sometimes we use array list. In initialization of array, some languages will allow initialization at the storage of a location. That means, for example, in C or C# or C++, in Java, this array, this is an example of C or C++ or C#, where the initialization, that means give initial value of the array at the time of declaration. Also, this can be done for character string in C and C++. Here you declare character array. This is the type of the array. This is the name of the array. An empty size, which is equal to the number of characters of this name. This is an initialization for character string. Also in C and C++, you can have arrays of string declared with a pointer, which is a star here before the name of the name of the array. In Java also you can have the string modifier with the name of the array and also the values. These are the initialization of the values for those. So the bracket empty, that means the number is already known to the Java program, which is 3 in this case, 3 in this case, 4 in this case. Heterogeneous array versus homogeneous. Heterogeneous array is the one in which the element need not be of the same type, and different types. Some of them are integers, some of them characters, some of them are floating points, and so forth. While homogeneous arrays are those that the elements of the array are of the same type, all integers or all characters or all floating point. This is also examples of array initialization. In arrays operations, in APL, for example, programming language, they provide some powerful array processing operation, as well as unary operations. For example, specifically if you use to in building database within the programming language, this used for reverse column elements. Python array assignment also. Python also support array catenation. Catenation means merging elements together, different arrays merged together to make one single string. Also Ruby scripting language provides such kind of array catenation. Here we come to the end of the video, where we will talk about rectangular and jagged array. What is the difference between rectangular and jagged array? The rectangular array is multi-dimensional array in which all of the rows have the same number of elements. And look at this, all of the rows have the same number of elements, while the jagged matrix has rows with varying number of elements. If you look at this one, it has some of the rows have some different elements. Yani this one has 6, 4, and 5. So if you compare this rectangular array versus jagged array, is a number of this is usually happens in multi-dimensional arrays, in which we have some of the values missing. For example, if some of the values are missing, this is called jagged matrix. In C, C++, and Java, so you can support jagged arrays, and F# and C# support rectangular array and also jagged array. This is an example for them. Slices is simply some substructure of an array. Yani, for example, this is slice, which is part of the one of the row. Part of the row is called a slice. So they are useful in some languages that have array operations. So in slice, you just need to learn about the referencing mechanism and how each element is represented by which one. So for example, this one is element number 0, while this here 6 number 3, or element number 3, 0, 3. So if you would like to get a slice, for example, that you talk about specific part of this, for example, this one is a slice, or this one here is a slice. Just like if you think about a pizza cut into 8 pieces and you take one, that is a slice out of this pizza pieces. So a slice here is just part of the array. It's just one row out of the array, or one column out of the array. I will stop here, and then in the next video I will try to finish up this chapter, hopefully, by putting it into a second part.